Okay, first things first. Numbers in programs. People quite often write things like, if eggs happens to be 12, then do something, whatever it happens to be. I guess I should make a variable for eggs. Right? So you've got this thing in your program, and then farther along you do that thing. What's the 12 for? Probably a dozen, right? And so the rule for code is that these sort of arbitrary numbers that appear in code are generally a mystery, and you want to give them a name. Okay? So one of the things that you could do to try to make things clear is you could say dozen equals 12, so that you can now change this thing to say if eggs happens to be exactly a dozen. Okay? And so there's this idea of let's give a name to a number. Okay? But the other thing, and that also helps you in the situation where further on in your code, if you happen to do another check, if eggs equals dozen again, now you've only got a dozen recorded once. So if you're making a change to the program, if this was a value that could actually change to something else, you only have to change it in one place. It also prevents this thing from happening. Just have to think of another one here. What's another thing that comes in 12? We'll pretend it's football teams. Or actually months would be another one. No, football teams. Right? So if you'd left it as 12, and you have code like this, then the 12 means two different things. In one case for eggs it means dozen, in the other case it might mean number of people on a football team or a rugby team. And somebody comes along and says, oh, we're not going to play with 12 people, we're going to play rugby sevens, so let's go change all of the 12s in this code to say 7 instead. Okay? Do a global search and replace, and all of a sudden eggs in dozens starts to be 7 instead of 12. Okay? So this is a good thing, because now this number, what you would do is you would say, people on team, or whatever you want to call it. So that now you can have two different variables to represent two different 12s. Okay? Now the names appear all the way through, so this becomes dozen. And they only show up at the start of the program as having those values. Every place else you use the numbers. Okay? So that's a fairly standard little programming trick that you want to play. The problem with this next is that this thing is actually a constant, and you really don't expect people to come along someplace in the program and say, accidentally go, oh, here's this dozen variable, let me change dozen to 15, which would be a bad thing. So whatever this number is up here, we don't want it to change. So the way that you do that is you would put a whole bunch of words on here. I'll do it this way. Actually, I'll start with this. I have to say static, I can't remember. Do something along that line. Just let me save this and get rid of some of these errors. That'll be a little better. Oops. Oh, it's in the wrong place. We'll put it up at the top of the class, like that. Okay, so now everybody in the class gets to see it as a constant that's not going to change. The other thing that happens in Java particularly is to try to differentiate that from a variable. It's now a constant. Constants usually end up being written in uppercase instead. Okay, and so that means when you see them in the code, you know now that they're not a variable that you can play with, but they're a constant.
They're the same color as
They're what?
They don't change the color of them, I guess, is maybe
No,
easier to identify.
no. But notice now, it doesn't allow you to do this line because that thing's declared as being basically permanent. It's get assigned a value and then the value's never going to change. Okay? So now the compiler says you can't do this anymore because we know that it's a constant. Okay? Which gets rid of one source of error. Okay, so that's one way that that constants end up being used. Typically, if you're running multiple words together, the other thing that will happen here is that you'll use underscores between the capital letters. Okay, so they're special, they're constants, and then the only way that you can separate them to make the words stand out, since they're in uppercase, is to use the underscores. This is also really traditional in C and C++. In particular, use that same sort of style, which is really where it came from. Okay. Well, now let's turn around and let's do another example. So now that you've seen one of those, the next thing that happens is that you get, instead of one of these constants, you'll start to get multiple constants. And so let's just make one here for easy way of this now. So we'll give that a number, and west will be another number. So here's another strategy you'll see where you have a group of words that are all related to in some way. So in this case, it's directions. Months would be another one: January, February, March, April. So rather than numbering them 1, 2, 3, 4, 5 and having people see the numbers, this just reads better to give the names to all of the months. Okay? There's still numbers internally, which makes them easy to deal with. The normal place where you see them dealt with is you'll have something like this, where you say in current direction equals north, and then someplace along the line we probably have a case statement, which you've never seen before, or switch statement, where somebody's actually going to use it, where they'll say switch on current direction, and then we'll just make up a quick set of cases here. So south would be do whatever you happen to do here. I'll just put a print statement in here. Just to get something in there. And then the way you'd normally see the switch statement, I'll just put in another couple of cases. Guess might as well put them all in just to be thorough. Do something like that, and so this would be south. Okay, so this is, depending on what direction you're going, print out some message to let people know where you're headed. Okay, so that's pretty much a standard sort of switch or a case statement if you've never, assume you've seen them before in some of the other languages. It's really just an if-then, it's a fancy if-then-else. So instead of saying if if current direction equals south, print this, else if current direction equals north, print this, else if direction equals that. So it's just really a cascaded if then else, but written in a way where it's maybe a little easier to just eliminate all of the gobbledygook. Okay. You can also combine cases in this case. So if you had two different cases that were the same thing, you can just print their names up there. And so the trick is that this number has to be an integer, or traditionally has had to be an integer, and that thing there also has to be an integer for this whole process to work. Okay. And the other thing that we'll see happen here is that what tends to happen is these numbers are all sort of associated together. So the other trick that we tend to do when we have these groupings is we'll add a name to the front of them. So I'm going to change this thing to say, put the word direction on the front of it to try to tie all of these together. Because you end up with lots of these things. So I'm going to do that, for instance, and we'll do the same thing to the other one. So just as a good programming practice, I would try to somehow show that all of these things are being used for one purpose and they all relate to each other. Oops. And one last one. Okay, so that would be another good practice that would just try to say, okay, now I group these variables together at least by name to give the sense of their purpose, and if I see them, I know they all belong together. Okay, so that's just quite often a naming convention that you'll see for them. Okay, and those things are just basically, anytime you see them at the front of a program, they're constants. And quite often you'll see that people will make these constants public, because that allows other people to use them outside of the class, and because they say final, they're not going to be changed by anybody else. Okay? The static keyword is on there or on the front, usually to say if we make multiple versions of a class, those variables are common amongst the classes because they're not going to change. Everybody can share the same numbers. Okay? So it's a sharing feature amongst things in the same class. Okay, so that's just generally the phrase that you'll see to have them written for constants. Okay, is there a problem with that? You would think no. Well, let's just give something a try here. I'll just do another one down below. How about this? What's the problem? How many numbers have we made?
4.
Are we ever going to have more than 4 directions? Sort of unlikely, you know. So the problem here is that you can set this thing to whatever you want because it's just a variable, and there's nothing that says it has to fall in the bounds of what your expectations were. So same thing for months, right? There's only ever going to be 12 months, but you can come along and you can set your months variable to accidentally 130 or 120, I guess, instead of 12, and the code will still try to do something with it because we're not restricting the range of the number because we're saying anything will do for an integer. Okay, so it sort of works, but it has the potential and to be very error prone because there's no way of restricting that variable. Okay, so now we get to the next thing that you see in programming languages. I have to remember my syntax for this one. So what this has done, if you sort of look at it, is it's made what looks like the name of a class, and it's saying that rather than putting this word on the front, I've just stuffed the names in to make them properly appear. Okay? And now what you can do with that thing, I guess I'll put it up at the top so that you can see it a little bit better, is that you can now say directions. Since I've already used current, I'll just call it a direction. I think I might have to specify the, oops. Okay. And so now what happens is you treat this thing like it was how you declare a variable. The kind of thing it is it's a direction. And now that variable can only hold valid directions. So you pick the names out of the thing and you can use them. Yeah?
I'm talking about directions correlates to direction.
To which? This stuff?
Yeah.
They're totally different. This is a better way of doing the same thing. Okay? And the reason it's better is because now if you try to say a direction equals 123, it says, no, you can't do that. The only valid things that you can use there for names are north, south, east, and west. So now I've basically restricted that integer, if you want to think of it that way, to only holding 4 values. Okay, does that make sense?
Yeah, I'm just wondering where you get, like, so do those north, south, east, west correspond to a number now?
Yeah, basically all that's happened, really, is that now instead of you assigning these numbers, this thing quietly does essentially the same thing. It sets north to 1, south to 2, right? So the numbers are still hidden behind there. You just don't get to see the numbers anymore, and you don't care to work with them. Plus, you get the restriction of you're not allowed to change it to something that's out of bounds. Okay? And so now this one you can't do that versus the one below because it was just an integer with some names assigned to numbers. You could change this one. Okay? So it's now going to be less error prone because now you can't do that. You can still use it in a switch statement. So now I'll just, I guess I'll steal this one because it's there and take the same idea and write it up top. So you can say switch on a direction, and then this thing becomes that word instead. Actually, I think if I'm lucky here, I can just do this. See if it's smart enough. Yeah. And so I got rid of that ugly word on the front because now it knows it's a direction thing. That's the kind of variable that we're using is specifically for direction. And so now the case statement just becomes north, south, east, west.
So then whenever you're changing the value in a direction after the initial assignment up there, do you still have to have the directions word in front of the direction?
Yeah, I think so. We'll just give it a try. So it doesn't like that. You still have to say directions. There is a way of avoiding that, but for now that's not bad. Okay, so you can reassign the variable to refer to a different direction, just like you could as if it was an integer. So it really is truly just treated as an integer. Okay, well, if that's the case, how about this? Did I do that right? Well, almost right. This is sort of what you'd like to say. You'd like to use the word directions there, but there's a little trick here. It's actually directions.values of each of the directions. We'll print out some direction and just see what it does. Oh, look, it prints out the same names that we had in capitals. So there's the loop doing its thing. Okay, so even when it prints out, even though there are numbers essentially behind the scene that looks like this, when you run a for each on it, you can go through all of the things, all of the values for it, and what you see being printed out are the actual names of the things rather than their weird numbers. Okay, so they're still hiding the numbers from you. You still get the names, which is a good thing. Okay, so just like anything else that has a bunch of stuff in it, you can still choose to run a for loop through it. Lost it, it's up at the top. You can still choose to run a for each through it. It's just that you have to call that dot values thing in order to get the iterator out to make it usable. Okay. Now there's all sorts of other fancier stuff that you can do with it, but that's, you know, the sort of the basics of how you'll see it. And so this becomes the preferable way for making constant values in a program, for names for things that somehow belong together. Okay. Last call for questions on that one. We'll try something else. Let's see, another tidbit. Let's just leave directions for a second, and let's try strings. So there's something that you can do with a string, make the name of a string. Notice that string is capital S string, so it's actually an object. So strings are smart things that allow you to do a lot. And if you've ever typed name dot whatever, you'll see that there's just a whole bunch of things that string actually knows how to do, most of which we haven't bothered to look at. Okay, but certainly it does a lot. Oh, there's one of your favorite things. Are we doing regular expressions yet? Well, look, it turns out that you can do regular expression sorts of operations on strings sort of built into Java somewhere to do all of that joyous stuff that you spend so much time on. Okay, so it's there, but we don't necessarily need a lot of it. Now, one of the things I'll say is that there are lots of languages out there that are better than Java for manipulating strings, and it's largely because we don't do a lot of string manipulation anymore. We do a lot of I'll just take whatever string I've got and display it in a GUI, and it's not like we're doing a lot of work other than that. So in most cases, we're just passing strings around rather than turning them into something for a lot of cases. Okay, it turns out that doing something like that in Java is actually just a shortcut for doing this. Because it's an object, that's also allowed. Okay, and so there's our friend new going and making a new string like any object that you would expect, and then assigning it to a string variable. Okay, and this is actually more or less just a shortcut because typing that all the time is just really annoying in a language. So because strings are used so much, they wanted to make the shortcut, but that's basically what it does.
Okay. So the shortcut isn't made for objects we make.
I'm not sure what you mean.
If we have if we make another object like bicycles.
Yeah, objects you make don't, strings are just the exception. Strings are the only thing that does that. There's no special way of doing it for you. Okay, it's just to make the string typing easier. Okay, so there's a couple of strings. Okay, the other rule about strings in Java, which is slightly strange, is that strings are officially immutable, and immutable just means that once you make them, they can't be changed. Okay, so the interesting thing is that when you do Fred plus equals some other character to get Freds, okay, oh sorry, name. So we'll just use that. And we'll see if it actually does print out Freds for a start. Okay, so there's Fred with the Z tacked on it. Okay, the interesting thing about that is that this original string Fred, because it can't be changed, means you can't just tack on the Z. And what it's actually doing there is it's actually making a brand new string object with Freds in it, and so it really becomes the equivalent of more or less doing this. What did we have here? Okay, so I'll make a new, I'll concatenate these two things together, and then I'll make a brand new string, and then I'll stuff it back into that variable. Okay, so when you do that, you're actually getting that. Okay, so there's been a couple of attempts in Java. This thing isn't too efficient because every time you do anything with a string, you're making a brand new string. New is sort of expensive, and so there's a couple of other classes that have been created whose names have changed recently. There's one called, added to, there's one called string buffer, and string buffer sort of looks and behaves almost exactly the same as string, except it's not immutable, so as you can do concatenations to it, it does what you'd expect, and so it's more efficient, okay, in the long run. And it's now become string something else. There's another version of this whose name escapes me because this one wasn't quite good enough, and so there's actually two non-immutable strings that have been added to the language fairly recently.
So I have a really random question. A while ago they were talking about making a printf in Java. Did they actually get it?
Yeah, the printf is there. You just don't want to use it. Okay. So there are a couple of other classes who, but in general, I'll put it this way, unless you're doing a whole lot of string manipulation, and I mean a whole lot, and you want it to be really, really efficient, you don't really care. Okay, so there's only this word of warning that if you find yourself, you know, doing hundreds of thousands of iterations of things with strings, that maybe there's a better and faster way. Just a few hundreds, a few thousands, general, who cares? It's not going to make any difference for the kinds of processors we're running on now. But this little decision to make strings immutable, they did for a very specific reason. And so let's just do a couple of things here. Let's just suppose that we make another string. We'll get rid of this one, or just use a brand new one. So there I'll use new here. I'll do it the long way to make Sam, and then I'll do string other equals new string Sam. Okay, you know that you can compare strings with the strings equals. like that. True or false?
True.
So it's going to print out that message, strings are the same. Okay, let's just see if it does. Cool, strings are the same. Okay, now we'll test your knowledge of double equals. Suppose I change this to say Sam double equals other. Won't print out, or you're saying it's double equals isn't going to work because
They're not the same variable.
they're not the same variable. They were done with two different news, so they have the same contents, but they're two different people with the same name, to use that concept, right? So obviously it's going to print out, it's not going to print strings are the same. That was Fred and ZZ, testing Sam against other. Yeah, okay. Okay, so perfect, right? Works just like you'd expect. Let me make one more change to this. Let me get rid of the new that's there. Is it going to print out strings are the same or not? Still the same deal as the last one, because you know that's what that thing is doing anyway. It's just basically calling new to do the work. Let's see what happens there. Oops. Here's the big reveal. It's a miracle.
Does Java already see that a string with the same value exists and just automatically point the other one to it when you do it that way?
Well, remember, this gets back to the roots of Java. Java 1.0 was designed 15 or 20 years ago by Sun to be suitable to work in toasters and in embedded environments of the 20 years ago, when you had processors that were meant to fit inside a phone or a toaster, and they were, there wasn't much memory and there wasn't much processor speed. And so what do you do to conserve memory? It turns out that a lot of your memory is taken up by user strings, where you're trying to print out messages to people. And they discovered that since a lot of the strings were the same typically, that what you could do is they would actually just say, well, okay, if this thing is going to be the same, then we'll say that if strings are the same and you can't change them, we'll just make them point to the same memory address. Okay? And so the difference is that if you look at these two in the debugger after they've been created, they actually have the same memory address. Okay? And you'll see this with their ID numbers. Okay, so here's double equals, and we'll go take a look at Sam and other. And notice that even though they were created separately and they look like two different strings, in fact, they're sharing the same address. So same string. So it's a memory optimization. I want to merge strings together when I see them, when I'm compiling them into the same piece of code. I know they're not going to change, which again was likely in an embedded device. They're going to be coded into the memory someplace, unlikely to change. That was a good optimization. Okay, so hold it here. Let's do another one. Let's stop that one and see if I can do one more example before time runs out. Let's put this back to the way it was with no, actually, let's leave it like that. Okay, so now they're the same. What happens if I do this? They're the same there. What about that? So put it up here.
Show
Could be.
strings with different memory locations.
The run button. That slow. Didn't print out the message. So they were the same, but if you add a character to them, now it has to put them in different memory locations because it can't change the one that's there, and so now they're suddenly different even though they both got the same characters added to them. Beginning to get the idea? Okay. So the same sort of thing would happen if we started and did and played this game. You know, you can have one Sam and you can have yet another, and you can start out with yet another as empty, and then you can do, you know, build the string the long way, et cetera, right? So same idea. If I build a string somehow to get it to be something, then double equals isn't going to be useful either, because the one that's built is different than the one that's that way. So if I build yet another with SAM and checked it against the original SAM variable, there's still two different strings. Did that just get really confusing? Okay, so you see what's happened is that they made this design decision in the language for a specific reason. It resulted in some weird sorts of side effects, okay, when you're comparing strings. And sometimes they will and sometimes they won't, depending on how they were made initially and whether or not they've changed since they were made, okay? So what should you do here instead of using double equals? So this is the reason for always using dot equals for strings, because if you use dot equals for strings, all of that madness goes away, and it always compares character by character by character, and you always get exactly what you want. Okay? And so help me, if you write code that has double equals in it for strings, I guarantee that someplace along the line you'll do the wrong thing accidentally, and you'll never be able to find it in your code, because it will have just been some character that got accidentally added. Now there are two different things that you thought were the same, and you'll just never know why, and it's almost impossible to figure out. Okay? So the rule is just basically always, always, always let the string do string comparison on each individual character, and it's guaranteed to be 100% right all the time. Okay? And it's sort of the exception to the rule of what you do with other objects where you're trying to check for identical with things. It's a little bit different. Okay? And so there's some string tidbits for you that all boil down to one real simple rule. Okay? And that's a good place to stop for today.